In this video, we will use the alignment, profile, and assemblies to create the track corridor, and we'll go over a few ways that we can do this. To create the corridor, we will go up to the corridor and choose corridor. In the corridor dialog, we will provide a name and choose the alignment and profile that we want to use. Then we'll pick the assembly, and we can modify this later on. We won't pick a template, we don't have one of those set up at this time, and then we will choose the target surface. So in the parameters box, we can make changes to any of these items like the assembly or the profile, and we can refine the start and end station numbers, and we can do that with the station picker. And we have marked a few breaks in our corridor that we'll pick for the end of our regions. In the frequency dialog box, we can determine how the corridor will process and which points will be targeted horizontally and vertically. In the target dialog, we can identify which alignments will represent the left and the right track and the profile. And we can do that by picking from the list of alignments or by choosing those in plan view. And we can determine the target surface under the surface tab. In this example, we will add regions after the first region and demonstrate this process. So we'll pick the assembly, and let's choose this time a wall assembly. The start station will automatically populate based on the previous region end. And we will use the tracking tool to determine the end station in our plan view. And we'll likely need to update the frequencies from the default set values. And we need to identify the target alignments for this region again, and we will need to do this each time we create a new region. And we can set up the frequencies and targets after all the regions have been added, but this process will take a bit longer for setting up the targets since there are so many different subassemblies to choose from. And so with only one surface, it's much easier to determine the end conditions and the target surface. Once we're all set up, we can select OK and build the corridor. As we inspect the results of the corridor, we can view some of those transition areas. And to get a better view of the corridor in section view, we will select the corridor and choose Section Editor. In the Section Editor window, we can fix our view either on a set, offset, and elevation, or we can base it on our subassembly. And in this view, it's somewhat difficult to see the layers with the grid pattern, so we can set our view options and change our style to all codes. And this will let us see the shaded sections. And we'll pick the subassembly that we want to focus on, our double track section. Here we can see different locations along the corridor, and we can inspect for any issues. So now let's create a corridor using a slightly different setup. We'll provide a name, the alignment, and the assembly. We'll define the begin and end station limits. We'll set the frequency and the target parameters, and we'll do those both in plan and in profile view. This time in our corridor, we will choose to split our region. So let's do that. And we'll do that at all our defined transition locations. Those values will appear in our parameters window. And let's update each assembly for each region. Now the advantage of this method is that all of our targets inherit the first region and parameters that we set up. So if we know our typical section limits or the location of where our regions will begin and end, this is a method that will save us a lot of time in our setup. One other element we want to look at is a target for our platform area. We previously created a subassembly in the last video, and we want to use the platform edge lines from our plan view. So we will pick our left side offset and elevation using our platform lines, both for inside and the outside. And we'll pick the right side as well with the same workflow. And now we run the corridor, and we'll take a look at our sections. In some transition areas, we might see where our corridors or feature lines don't behave the way that we want them to. In order to remedy this issue, we can adjust the station limits between the regions and create a very small gap. And in this case, we'll just use a few millimeters and rerun the corridor. Now, when we review that, we can see those corridor lines are much cleaner near those transition regions. So next, let's create another corridor using our ballast only and the skeleton track assemblies. Now, this is an easy way to model our corridor when the eastbound and westbound tracks have different cant values, which is pretty common. If needed, we can add cant to our center align alignment, and this will provide some super elevation for our ballast surface. And once we set that, we will set up our corridor the same way. This time, we will pick our ballast only for the assembly. And we can split our region. This time, we'll split it for the platform area. Now we need to add baselines for our track. So let's add the eastbound track first, and we'll define our profile. And we'll use the skeleton track assembly, so it will just show the rails and the ties. Then we'll add the westbound with the same parameters, and then we can build the track corridor. Now in section view, we can see the different cant values for eastbound and westbound, and we did this intentionally for this example. But as we move along the corridor through the sections, we can see the cant transition along our curves. One brief demonstration for corridors. When we set our targets on the rail alignments, the assembly will adjust to find that alignment. So if we adjust the location of our alignment and rebuild the corridor, we can see those updated changes both in plan view, and we'll look at the same thing in our section view, and we can see how those transition together. Now let's create a corridor transition. We have an area with special track work where we want to create another area for the switch machine, and we want to do that on each side for this crossover. So we will select the corridor and pick corridor transitions. Here we'll define our baseline. In this case, it's a center line between our tracks. Then in the transition window, we can pick create a new transition set. Then we move the cursor in plan view. We can actually see the different assemblies highlight. So let's pick the double track assembly. And once we do that, we'll see the parameters that we can transition. And these could be horizontal or vertical elements. And there's a number to choose from, but let's pick the right ballast shoulder here. Next, that'll ask us to define our start station. And we can do that with the tracker. And we can input the beginning value, and it will tell us what that initial value is set at. And we'll keep that at 0.5 meters. And then we can pick the transition station and value. And this time, for the transition, we'll pick 2.5 meters. And this will be a linear transition. And then we can pick the next section with the offset values. And then the final section, and we'll provide the end transition numbers here. And if we need to adjust any of our station values, we can do that by inputting those values here. And we'll make these numbers easy, and we'll round up to the nearest 10. Then we'll choose Apply. Once we do that, we can see each section in our plan view, or we can view the entire set. So now let's copy this for the other area. We'll give that a name first, and we'll lock it so that those transition spacings will stay the same. We'll paste that, and then we'll change the name for the left side. And here we need to transition for the left ballast shoulder. Now, if we try and relocate the first position point on the tracker, we're limited to the end station of that first section. So let's pick the final value of our end transition and pick the station we want in plan view. Now, because we had it locked, all those values will update respectively. And if we adjust that station at the end, we can update those again. Then we'll pick Apply, and we can see the switch machine transition locations. Now let's look at a final example for a multi-track layout. We have a yard here, and we have it laid out with several different tracks, and they're all parallel. We've identified a midpoint between the tracks that we want to use in our subassembly, and it's a feature line. So we'll go through the same process to set up a new corridor. Now in the ladder area, we want to use a 2-track layout. And we'll pick the yard lead as the left track and the main line as the right track. In the middle section, we want to use a single track region for the main line, and we'll use that as our right track. Then we can close the ladder the similar way that we started it, with a double track region. Now let's build this right now. In the ladder area, we'll use skeletonized track for our layout based on the alignment and the profile. We also want to add a baseline for each track. And then we'll define the station limits for each region. And in this middle section for our interior tracks, we need to use those feature lines to define the edges of our ballast. And we'll do this for each track in the yard. And once we rebuild that corridor, we can view that in the section view, and we can see those ballast sections line up very nicely. And we can see how that ladder transitions for each area as we pan through those sections. The last thing we'll look at is adding pay items to our corridor. So under the Analyze tab, we can select the QTO Manager. This tool allows us to add pay items to our content in our CAD file. Now we could use the default values, but we have a pay item CSV in our project directory. And so we'll load that here. And then we'll add the categorization file from the same directory. And this will show us all the pay items that we can assign to the different objects in our file. To add this data to a corridor, we'll select the corridor and pick Corridor Properties. And we need to define these pay items in our code sets. So we'll go to the Code tab, and when we view our codes, we'll see that there are no pay items defined in our list. So we need to edit those codes, and we'll select that here. And under the links and the points, we can define the different elements of our corridor, such as the ballast or the track, that may need a required pay item number. So now, when we select Takeoff Quantities, we can calculate the values and see what is derived from our corridor. So these are just a few different ways that we can set up and create a corridor for rail and track projects. In the next video, we'll create cross sections, we'll set up our plan and profile sheets, and we'll look at volumes and quantities.